Okay, example 7. We are to evaluate these two seemingly identical limits. There is one small difference. Here we've got positive infinity, down here we've got negative infinity. A small but important distinction. Something else we want to keep in mind is that although x plus 5 is a rational expression, x plus 5 is a polynomial, and the inside of the square root, 4x squared plus 3x plus 1, is also a polynomial, because that polynomial in the denominator is underneath the radical of the square root, that means this entire expression is no longer a rational expression. So that's why we're taking two different limits here, because there could be a distinct second horizontal asymptote depending on which direction towards plus or minus infinity we go. Okay, but we can still use a lot of the techniques. So let's go ahead and use the method of dominating terms to rewrite this limit as the limit as x goes to infinity of, well, the biggest term in the top is just x, and in the bottom, within the square root, it's 4x squared. But this square root still sort of affects what this is. So let's think about it. If x is equal to, let's say, 10 to the 10 to the 10, a really just unfathomably large number. If we take an unfathomably large number and then we square it, that is so much larger than these two terms. These two smaller degree terms have less and less of an effect as x gets bigger. So when x is very large, and we're going to infinity, so it's big, we can think of it as being as big as we like, eventually these terms are insignificant. So really, when x is very big, this square root sort of behaves like the square root of this first term, neglecting these later smaller degree terms. So be sure to carry that square root with you. Don't neglect it, because it is acting on that 4x squared. So once we have this, it's time for us to simplify. And when we simplify this, we got to be careful. Square root of 4 is 2. Square root of x squared is not, unless we have more information, the square root of x squared is not x. The square root of x squared is absolute value of x. Okay? But we do have more information. What do we know? We know, so I'll say, but since x is going to positive infinity, we may assume that x is positive. And we know that since x is positive, the square root of that, the absolute value of a positive number is just itself. So that means I can actually shed off those absolute value bars, and then we can go ahead and simplify this by canceling those x's, and then we find that the limit here is equal to positive 1/2. Now effectively, all of this same stuff happens again for the next part. So let's just make our lives easy and let's copy paste it. I'll have to move some of this, but there you go. And effectively, what we end up getting here is the small change. This step is the same. Oop, I guess I should toss in some negative infinities. Okay, so this step, it's the same. This step is the same, but we have to go ahead and say, but since x is going to negative infinity, we may assume that x is now negative. And it just so happens that the absolute value of x, if x is negative, then the absolute value of x is equal to negative x. Because if x itself is negative, then the double negative, the negative on the outside and the negative that is sort of embedded within the x, will cancel each other out and give you a positive. So this negative here on the outside is to counteract the inherent negative in that x. So what we can do here is when we go ahead and rewrite this absolute value, we have to write this as x over 2 times negative x. So this implies the limit right there. And then if we compute this limit, again, the x's cancel, but that negative remains. And so we have negative 1/2. So this expression does, in fact, have two distinct horizontal asymptotes.